Welcome to the stream, everyone. Today we are going to be jumping into some phaser animations and get our characters jumping as well. Last time we took a look at the classes or JavaScript inheritance, how to structure out classes and subclasses and build out a hierarchy to create objects within classes that inherit certain properties. So we'll be doing some of that today, but if you want to go catch up on that video, it's on Twitch. Once it expires on Twitch, then it will be on YouTube under the same channel name, Noctophonics. You can go and search that and find all of the videos that we've done so far in JavaScript, watch the whole course to catch up. But if you want to just jump right in where we are, we're going to get started with phaser animations. All right, jumping back into learning phaser, specifically the use of classes, animations, and tweens. Welcome back to the world of phaser. Put the class Notch under your belt and get started with making multi-scened phaser games. You'll see firsthand how we can transform a single scened game that you already created and make it into a game that has a start scene, a gameplay scene, and an end screen. After learning about multiple screens, you'll continue to develop your phaser toolset by learning about phaser animations and tweens. Animations allow you to take a sprite sheet and make your sprites move. Tweens will also help you manipulate sprites as they transition through their animations. You've got a lot to learn here, so get started. Alright, we shall get started. First up, lesson multi-scened games. Building a multi-scened phaser game. Phaser games are defined by scenes. In a simple game, we might only use one scene. In more elaborate games, we can use multiple scenes to build out start screens, end screens, or even different levels. In this lesson, we're going to refactor or rewrite the code differently but still achieve the same outcome. An existing game's code to include multiple scenes. Along the way, we'll discuss how to organize our code so that it is easier to maintain and debug. With these techniques under our belts, we'll be well on our way to build out multi-scene games with phaser. Alright, so look over the different files and see how the code is organized, then click on the game to transition through the scenes in the browser. We will gradually apply this same logic to our code in the later exercises. Alright, so let's take a look here. So it looks like we have 3 scenes set up for our viewing pleasure. We also have the game.js, which just stores the game state file, as well as the config. We've done quite a few where the config and the game state object are just within the same file, like the same scene as everything else. That's fine too, but if you have multiple scenes, then it's good to keep it separate, just in case you want to change like how it's displaying or any of the background colors and things like that. And then of course we have our HTML file here that's just helping us populate something on this canvas, creating the canvas itself and loading up our phaser script. So those are the 2 simpler ones. Let's go ahead and look at the scene itself. Okay, so they've got a class of scene 1, so they're establishing a new class. Then that scene, that subclass, extends the phaser scene. So phaser scene is the built-in parent class that they're referencing for this, which in itself is a property of the phaser, the large phaser framework object. Then they have a constructor that's putting through a super, which we learned about that last time as well. This basically feeds it back through the parent class. So it takes whatever property you give the constructor and feeds it back through the phaser.scene class. And then they have a create. They're just creating the text on screen. And then they have an input event handler for when the pointer, or whenever you click and hold, right? Or whenever it's clicked, not when the pointer lifts up, but just as soon as you push it down. Okay, so I think that's all we need to know about this one. And just to know that what the super is doing is basically establishing the background and the canvas size. So in the game file, the game.js file, we have our config set up. This is being put into the phaser game, and it's establishing a property of scene in the phaser object. See that? So this is really cool. We're finally like finding the roots of everything we've been working with so far. So when we declare a new game, right, new game variable, we then call the class, or make a new class, or sorry, not make a new class, make a new instance of the class of phaser, and then input the config within its game property, which gives us all of these properties. So when the scene extends the phaser scene and then uses that super, it's taking everything in here, and then scene 1 is inheriting all of those properties. Okay, so, and oh yeah, it's doing that by basically replacing itself in the place of the game. So the game has all of the config properties, but here we're using a key of scene 1 to be input into where this is. So then that would inherit all of the properties within the config file. Cool. Okay, so this is the first scene. Let's see, before we click anything, we know that once we click our pointer down, it's going to start scene 2, right? So we click, and then it says this is the second scene. And what's happening here is the same that was what was happening in scene 1, except the text is different. So scene 2 is also an extension of the phaser scene. It's inheriting all of the properties from that constructor or the config file that we saw, and then it's adding a new text. When we click this one, the third scene will start, and the third scene is set up the same way, but it has a different text here. And then when you click this one, it goes back to scene 1. So it's a full loop all the way back to scene 1, and you can click it as fast as you want, and it will always keep switching. Now, you could do something where you have like the super and then add in a background that's unique to that scene. We won't do that yet, but that's what you could do to tell that you're actually switching scenes. Because right now it just looks like when you click, the text is moving, and that could be easily done with one scene. But if you see that the background's changing, then it might give you an indication that there are more than one scenes. Yeah, okay, so let's go to the next page, using classes in Phaser for ES6. Oh, here's our bug game again. Let's see if we can, yeah, it still works. They put in all the functionality of the bug game. We can't shoot. This was the falling bugs game. Just loaded that up for us. All right, so in this exercise, we're going to refactor the code from the physics lesson. One major change that we're going to implement is the inclusion of the JavaScript's class syntax. Each class will represent a scene and contain a familiar preload, create, and update functions. We're going to refer to these functions as methods since they're functions that belong to a class. Below is a sample. All right, so we've got the class that extends the phaser scene, just example scene. They're using that super that loads up all the config properties and allows this class to inherit it. And then they have our three well-known methods built in there: preload, create, and update. In order for our phaser game to know about this class, we'll also need to change the config object. Interesting, so scene, example, scene. Let's see how they explain this super here. So inside the constructor method, we call the super, which calls the constructor of the phaser scene. We provide super with the object key example scene so that we can refer to this class in our config object. Okay, so then preload, create, and update are included, but are now methods. Notice the lack of the function keyword. Right, so those are just declared as methods, and you don't need that literal word function. Okay, so I guess the super does something a little bit different than I thought. Okay, so this is instead setting it up so that we can refer to it in our config object. Actually, if we go back, let me teach myself something here. I think I saw that within the config scene, we have the possible scene 1, scene 2, and scene 3. So these are like all of the possibilities that we can have within our scene. And then that's also letting the property of the scene know that that's the current scene we're on. So in this example, in order for the phaser game to know about the class, we also need to change the config object, simply meaning that you set up the scene as a possible scene. In the code above, our config object scene property has a value of an array. While the only element currently inside is example scene, we can later add more scenes to the array. By refactoring our code, we're laying the groundwork to include more scenes in this existing game. And in later exercises, we can add scenes for starting and ending the game. All right, step 1, create a new class called Game Scene that extends Phaser Scene. Class Game Scene. And remember, these are all Pascal cased, so anything with classes, everything is capitalized, even the first word. This will extends phaser.scene. Okay, and I don't know that we're giving this scene any properties, but we're going to just create it like this. Inside the class you created, add a constructor method. We can do that very easily. Constructor Step 3, with our constructor set up, we need a way to reference game scene. So inside the constructor, call the super with the argument of key game scene. So let's call that super method. Inside of here, we're going to have an object with a key of just key, and then a value of game scene. Okay, so that'll make it available for our config file to reference. Now we can move all the preload, create, and update functions into the game scene class. Okay, so now this is actually going to be holding everything. So we have our function preload, so literally everything below, except for the config file. I don't think we're adding that in. We're just adding those 3 functions. So let's get rid of those and then input them into our class here. And make sure that's closing out nicely with the braces there. Okay, it's not quite tabbed symmetrically, but that's all right. We know what's happening there. Okay, so now we have our upload, create, and upload was very small in this one, update, create, and preload. And that is all contained within the game scene class. Okay, so then after copying the 3 functions, remove each method's function keyword. Yes, so if they are outside of a class, they do need to be declared as functions, but if they're inside, we can just get rid of that word there. And then we need to do that for the preload as well. So they can just be declared as methods since they're within an object, or in this case, a class. But notice I messed up the braces order because this was actually set inside of the constructor, and we don't want that. So let's create some space between the constructor and the bottom and get rid of one of these braces. And then when we reload it, it should work just fine. Yeah. So just make sure when you're adding it in, don't add it to the constructor, but add it to the larger class. All right, but now something is still off because we don't see anything on screen. So to be able to use the game scene, we have to locate the config object and the scene property, and then replace the default value with game scene inside of an array. So we need to delete these and just put in game scene, the class that we just created. And within the game scene, it'll have preload, create, and update built into it. So everything that's contained within there will be a part of the scene. And once we refresh that, everything should look good. Everything works the same as far as the game goes. It's just we are setting up more functionality for other scenes, such as a start and end scene. All right, so now, since we're now using the class syntax in our Phaser game, we can add another class that will render a start screen for our players. This start screen will give our players the chance to ready themselves before actually playing the game. Recall the template for creating a scene. So first scene extends Phaser scene, constructor, yada yada. Notice that we supplied the super with a key of first scene. We'll reference this in our config. Yep, we saw this before. This time we have 2 elements inside of the scenes array. The ordering is important in determining which scene the game plays first. For the example above, we will play the first scene and not play another scene until prompted. Let's add a simple start screen to our game. Okay, so add a class named Start Screen that extends phaser scene. We'll go ahead and put that above our game scene here. I'm guessing that once we build all this out, we're going to create other files for it. Ah, see? I took a peek here. They already created them for us. I believe, let's see. Game.js script. I'm not sure where I guess you can just add files up here, huh? Anyway, let's go back to the game scene. That's a future step. So we'll get rid of the distractions there. All right, so class start scene that extends phaser dot scene. Okay. Step 2, inside the class you just created, create a constructor with the super of start scene. Constructor super. This one is going to have an object with a key of key, and then start scene. All right. Step 3, let's keep our start screen simple and add a create method to the start scene class. Inside of this, add text. So replace the text argument with a string to tell the players that they are going to start the game. Okay. So let's see. Let's think of a name for our little bug falling game, right? So inside of this, outside of the constructor, but inside of the class, we want to start we want to add a create method. So create, and then inside of this, we'll have this add text, and then have it be X and Y in the text argument. So we'll go around like 150 and 200 for this, or 250. Yeah, let's go 250. I think that's where the game over, somewhere around there, like 180, 200 or something. And then a string that just says like the title, right? Like we need title text, or I guess this would just be like click to start, right? They'll probably have us do that anyway. They'll probably set up a handler for clicking to start. Okay. And then in 4, we need to add the scene property to config. And this needs to happen before the game scene array, like before that index. So we need to have start scene happen before that, and just separate those out. And now, when you order them, it just says click to start. It has it in white text because that's the default. Of course, you could add other, like we'll go ahead and copy our style object from before and use it here. If you don't supply it with a text style, it'll just automatically be like 12-point font in white. There we go, and now we've changed it black. In case you're wondering how to do this, simply you create an object for a style, a text style. You add in a font size as a string of how many pixels you want each character to be, or the maximum characters to be, and then the fill of whatever color you'd like, also in a string denoted by the hashtag. I also go over this in a little more detail in the previous lessons as well. But yeah, okay, so now we have a start screen, and then when we click it, nothing happens because we haven't put the functionality in. They'll probably do that next. Scene transitions. Phaser has built-in methods that make it easy for us to transition from one scene to another. For us to transition between scenes, we have to stop the playing of a scene and start the next scene. To stop a scene, call this scene stop key of scene. And to start a scene, you do the opposite. This scene start key of another scene. The stop and start methods take in a string that has the value of a scene's key. Like the name of the methods imply, stop will stop the scene and start will start playing the scene. Yes, we know that. We've actually used these before without ever setting up our own scenes. Even back in I think the Mole Unearther game had one of those where we had to start it and stop it based off of a certain criterion. All right, step one of this. For our game, we want to start the next scene after a player clicks on the game screen. So we're going to add a pointer up event, and we need to, inside of it, call this stop scene. So they added the pointer up for us, just this input on string of what you want it to do, what you want it to listen for, and then a function. Inside of here, we're going to put in this scene stop, and then our key is going to be start scene. This is going to be a string. And then now inside of this, we're going to, inside of the pointer function, we're going to then start the next scene. So this scene stop or start. And the next one is called game scene. That's interesting. So I knew they were going to have it like that, just like click to start, because they tend to do that where you click the browser games to start, and they did load that in. They made it twice as large as we had it, but hey, that still works. Tells the player what's going on. All right, so now if we click it, it'll go to the game scene. Look at that. Now we have a start screen. So cool. So cool. What does this have to do with animation? Well, nothing much yet. It's a scene transition. We're still kind of in the class world right now. Still learning what classes can do for us in the context of Phaser. Separate files. Having two scenes, a game state object and our config object in the same file can make our code feel cluttered. As we add more scenes, this will continue to grow. This file will continue to grow, and it can be more difficult to maintain. One way to remedy our growing code is to reorganize our code into different files and import them into the same game using script elements inside of our HTML file. We haven't touched this at all, so this is going to be interesting. They haven't even had us look at this. So currently, the body of index.html looks like this. So there's body, script, some other scripts with the Phaser version, and then the game file. So we can break up the code in game.js into files, each one containing code for a specific scene, so that our body looks more like this, where you have the Phaser version set up, the script loaded in, and then you have multiple scripts as, oh, that's interesting. I don't see it as like containing like game scene. This doesn't contain these as like sub scenes or anything. It's just creating separate files. Okay, so we'll keep each scene's code inside separate files to make it easier to maintain our growing code and to avoid the need to scroll through a single gigantic game file. Yes. 5 different files with 100 lines of code is better than 500 lines of code, right? It's much easier to manage. Okay, so let's take a look at our HTML and try to decipher some of this. So we don't have to understand all of the syntax, but we will shortly because it's actually pretty simple. Basically, they use the greater than, greater and less than signs to contain their code in this, and then some, looks like, what is that one? The / for the different parts of it. So they've already provided some new blank files, start scene and game scene.js. Where that's initialized, I don't see it though. It's just like within the game scene itself. To include these files in our game, in index.html, add 2 script elements below the script element that links the Phaser CDN. So the Phaser CDN is just this right here. So it's loading up the CDN link there. So we need to just add in one script that will have an src attribute of start scene.js and the other an src attribute of game scene.js. Okay, so we'll do a less than sign, a left caret, if you will, script, and then we're going to say src. This is going to set it equal to the start scene.js. Then the right caret greater than, right? Then this is going to have script. So left caret / oh, if we can get it there, script and right caret. There you go. And these within the HTML, unless you're working with like objects, they don't actually need semicolons. So just leave it like that. That's the first one. The second one is going to be like it underneath. We'll get some practice in, so we'll actually go ahead and type this out. So script rather than copying. src. This is going to equal game scene.js. And then / script. Okay. So those are our 3 files that we've set up. And then you can copy the entire code for start scene class from game.js and paste the code into start scene.js. And then remove the code inside of the game. So we're going to cut and paste here. So this is going to be the start scene class. We're going to copy all of this, just Control X to cut it out of the game.js file, and we'll add it into this file here. Now, if we added this before we set up the file inside of our HTML, or had it like reference that file exists, nothing would happen with the start scene. This is not visible by the game.js, so since we would only be working with that file, it wouldn't know what to do if it came up with any like start scene code. So we have to make it visible by adding it in to the HTML here. And that way when a start scene runs, it'll switch over to this file instead of remaining in the game file. So now we're going to copy all of our class for game scene, cut that out of the game.js, and bring that into game scene.js. And now that should be everything we need as far as transferring goes. So then the only thing left over should be our game state file and our config file, and then the initialization of the new game. All right, so that's step 2. Like we did for our start scene. Okay, so then we did step 3 as well. Let's see if we can run this again. We did that in one step. There we go. Now let's see if the functionality still remains. If we click it, it does start. Look at that. Look at that magic. HTML magic right there. And now let me show you what I'm talking about with, so say we created 3 files and set everything up like this, where our config file does have the start scene, it does have the game scene. So we think that it should work no matter what HTML we do. We don't want to code HTML. So let's go ahead and see if that works without this. It doesn't work because it throws an immediate reference error because it doesn't know where start scene is. All it can see, all this canvas can see, is the game file. So just the game.js file, this is all it's seeing. When it runs the config, nothing happens because it can't start the first scene. So, and then like nothing is built because there's no create functions, there's no preload, there's nothing. Nothing is visible. So that's why you need inside of the HTML all of the files listed here. Okay. All right, good job on refactoring the game. So we now have the ability to add additional features using multiple scenes. In this lesson, we covered the usage of JavaScript class syntax to include multiple scenes in a game, how to build multiple scenes to config, the ordering of scenes in config determines the first scenes to play, how to stop a scene and start a scene, and how to organize code into different files and incorporate these files into our game using script elements. Yes, indeed. So yeah, and then just like we don't have to go through this in great detail, but it's pretty simple. And just a once over look at this to see that the HTML is setting up our character set, which is just the UTF-8 English language with all the symbols and all the other kinds of crazy widgets or wingdings, whatever, that you have in there. It has a title, which is interesting because we don't use this at all. But that title must be like just for the developers of like CodeCademy knowing that this is the bug dodger thing with a 450. We might be able to access the bug dodger somehow and have it display, but it would be just easier to write that in our JavaScript. Anyway, so that's the head of the document. And then the body, it actually populates what is going to be within that canvas, right? So they set up the canvas with a width of 450, and then the character set for English, and then they can populate it with the phaser script as well as the files that we have in there. All right, so if you want to challenge yourself, create an end scene class to the game. Add more levels to the existing game. Well, we did this one before. We definitely added more levels when we actually coded the bug dodger, so we don't have to do that one. Let's try to make an end scene on our own. So we want to create a new file, right? So over here, if we go into our folder of all the files, I think at the top here, if we just create a new one. No, we don't want to create a folder. We want to create a file. So the document with the plus sign there. We're going to call this endscene.js. And I don't know if we need to type out the default. I think it will just automatically do that. Or it won't. Okay. Weird. I don't know if we need to have the parenthetical there. We're gonna see. All right, so we have an end scene, right? End scene. We can make this say something, so we can set it up like our start scene. But before we do that, we want to show that it exists within the HTML. So once again, it's always good practice to type it out, but I'm just going to copy this down because it's going to be the same syntax. And instead, just change the label here to end scene, and that way it knows that the file exists. Secondly, we need to add that into our scene key within the config object, end scene. And then lastly, we can do something with the end scene, and then code in a transition from the game scene to the end scene. Like whenever the win condition is, or whenever the physics pause. Let me see here. This scene restart. So if we start this game, click to restart. Okay. So say that the player reaches a certain threshold of points, and then it wins, right? So the player will reach, say, like 5,000 points, and then it will win. I guess we could put that in the update method here. So just setting in a win condition so that we can switch to our end scene. So what do we need here? So if score is greater than or equal to, although I guess we can just put like, yeah, not 1 million, but 10,000 there. Maybe just is equal to 10,000, which it should always reach that because it's just increments of 10. Of course, that's going to be really hard to test. So let's just say 500, right? If score equals 500, then this dot scene dot stop, and then you just put in the game scene, and then this dot scene dot start of end scene. And then once we have our win condition in place, what sends us to the end scene, then we can actually add in our class for it here within the end scene file. So class end scene. Theoretically, you could name this something else, like the file something else, but the class and what appears in the scene of the config needs to be the same. So end scene. Class end scene extends phaser dot game. Is it phaser dot game or is it phaser dot scene? It's phaser dot scene. It's only phaser dot game at the very start where you're setting up the config file. So these are extending the phaser dot scene. And then within this, we'll have a constructor with a super that has an object with a key of key, and then a value of end scene. Okay, again, this is just the link to the config file, right? So all of that, that string needs to be the same. And then we want to put in a listener, right? So after our constructor, we want to say this dot input dot on the pointer up. So whenever someone clicks, or is it pointer? It's pointer up, right? Not pointer on. Pointer up. This needs a comma, and then the function comes after that. So comma, arrow function. Let me get myself straight here. Let's put another parenthesis there. Equals with an arrow function. And then whenever someone clicks it, it's going to restart. So this scene, stop. This is going to stop the end scene. And then we'll have it loop back to the start scene. So this dot scene, scene dot start, and we'll say start scene. Or we could have it be the game scene, right? Like, because the start scene should only appear at the very beginning. If you go to the end scene and it says click to restart, you want it to actually start the game scene over again. You don't want it to like reboot the game. So that would be like going back to the title screen, whatever game you have, versus actually restarting the level. So, or restarting it. All right, so you could do it either way. I mean, if you have a nice, like, I think we did this with the Treasure Hunter game, or like the Mole Unearther game, or I think it was, no. It was Electric Mouse, that's right. It was the Electric Mouse one where we had an end condition. When we clicked that, it went back to like the start screen of Electric Mouse. So you could do that if you have a fancy image to show at the beginning, show off that title art. Inside of the constructor, we need to, or not inside, outside of this, we need to also create something. So let's make a create method and then say this.add.text. And we're going to have the same properties here. So let's say 150 and 250. This is going to say, congratulations. Congratulations. Or just like, you win. You win. Click to restart. Click to restart. And with these two, like in the time where we are actually setting this up where it would be over each other, I would usually create like two text lines and then label them differently. So this would be like add text. This would then equal game state dot such and such text. So then you could have separate lines of text. Because if you do it this way, if we can get to the end condition, which we can't because we broke something along the way, as usual, but I'll find out what that is. This add text, let's go ahead and see if this, you win, click to restart. That's all good, but we need to also create the event handler. Okay. We need to create the event handler. We can't have this outside. Right, because the handler doesn't exist unless it's created. unless it's existing. Okay, so let's do that. There we go. Now it's not broken. Wonderful. So click to start. Let's see if well, nothing happens at that point. Let's try that again. To start. Yeah, nothing happens. Okay, so what else in here is off? So we've got the braces going. Oh, give me just a second. There we go. Lovely dogs barking in the neighborhood. Okay. So in our create, we've got our braces set up, but let's see, do we have enough of those? Yeah, nothing is left hanging there. Got all of that. Scene stop, is that the right thing to say? This input on, yep. Pointer up. End scene, start scene. This scene start, this scene stop. Pointer up. Well, let's go ahead and add in our fill and font size as well. For the style of that text. Once it appears, we'll see it like that. Very strange. So if we delete this, if we delete the end scene, do we get something then? We get nothing because there's a reference broken inside of start scene. So we know that it existing like this is good, that we can at least have the start scene, and the transition works, but it doesn't go anywhere. So for some reason the game scene is not starting. Let me look over this file here. So the start scene, game scene, and end scene are all set up. We have them set up in the HTML as well. And let's see, so with the classes, phaser.scene is set up. Game scene extends phaser scene, end scene extends phaser scene, constructor of end scene, super key of end scene there, start scene, have that as well. So what is up here? Game scene extends phaser.scene, constructor super key of game scene, super key of end scene. Create all this. Yeah, I mean, it's literally, essentially what we're doing is literally the same as this, except the text is different. And then the start scene is different. But why doesn't it want to switch over to the game? If we get rid of this, what happens? If we get rid of the scope of that there. Still nothing. If we get rid of this also, and then restart it, still nothing. What happened with that? Get rid of this. Now it's just completely broken. Start scene, game scene. I don't understand now. Okay, so we're gonna have to redo that because it doesn't save undos on that one. Anyway, we can just redo this. So we copied all that, but okay, let's reset this one. I don't know what's going on because it should, like, okay, it functions just fine here now. So we're gonna go each step, save our code to see what is breaking when it's breaking. So let's first, let's first make a new file. Oh, you know what it is? You know what it is? I bet it's that we didn't have the default parenthetical there, which they didn't explain all themselves, but, you know, default parentheses. Okay. Now copy our code into here. What? Why is it not color-coded now? That's so weird. That default, but yeah, see, like, rename. If we rename it to endscene.js. Okay, that's very strange. All right, I'm not sure what's going on with that. Or how to make it be default without, like, literally typing it and changing the name of it. Not sure. All right, let's see if just establishing our file without any reference breaks it. It shouldn't, because nothing is being seen by the HTML. Okay, so now we copy this down and we give it our endscene.js file. Okay, still nothing should change. Okay, good. Then what we want to do is add it into here as the end scene. Okay, there we go. Yep. And then if we get to 500 points, that should be our win condition. Oh yeah, we didn't add that in. We add that into the game scene. So, oh, that's probably what was breaking. I didn't test that before. So within the update file, if score equals 500, maybe that needs to be within the create instead, like this. So then just if score ever equals 500. Well, I don't know. Can you do this? Do we need to have this within the? Okay, yeah, we do. I think every time you reference the, where is it? Yeah, that's right here. When you do a create method, you need to have the scene start and stop within that create, I think, because the update seemed to break it. So we're going to try it within the create now. This.scene, or unless we don't know what this is, right? Because sometimes this keyword gets confused when we put it inside of an if statement. But we'll try it. If not, we'll just change that to game state. So we're going to be starting this is in reverse order, but I'm going to be starting the start scene and then ending or stopping the end scene. Okay. Now let's see what happens. Yeah, see, then it breaks. Is score not globally known, or is it just this? Game state dot scene. Is that even gonna work? I don't know if that's set to phaser or. Yeah, it still breaks. So how do we access that? How do we access that? I mean, this keyword should still work, right? This scene stop, this scene start. Yeah, so I don't think it's an issue with our this keyword. Yeah, just doesn't like the conditional. Okay. Where is score stored? So score is stored within game state object. Well, are there other things in here? I mean, of course there are. There are other things that are referencing the game state object. So this needs to be game state.score because score is not a global variable. It's just the property of game state, which is globally available. So 500 should then show us the game. Perfect, so that was it. That was the whole issue. It was just, I didn't put game state in. I'm trying to reference a variable that didn't exist. Trying to reference a property as a variable. Alright, so if we get to 500, you can see nothing is happening. Maybe it advanced too quickly. You know, too quickly for it to notice. But again, we need to change this instead of end scene. The end scene needs to start, and the game scene needs to stop, right? So it was starting and stopping scenes that weren't even there, weren't even visible. So now let's see what happens when we get to 500. Oh, if we get to 500. So close. Yeah, this is set to 100 milliseconds, right? And we tested it out before, and like 90 milliseconds seemed to be the good spawn point. Okay, so as you can see, I don't know that I actually... Did I save it? I think I saved it. If GameState.score equals 500, it should switch to the end scene and stop this scene. But it does not. It does not. So... Maybe we need to have it be greater than or equal to. Try that. Try that out. See if we get to 500. Now, wait, is score actually not like... Is score only incrementing by 1? And then the points are different? You know what I mean? So like the variable's not actually changing to... yeah, because still it's not working. Maybe this doesn't need to be in the update because it just runs once and then doesn't do anything. It needs to check it every frame. Yeah, and everything will still be scoped within the update. So if GameState.score, like so. Let me see here. Let me see here. Waha! It's all out of whack, but hey, look at that. End scene came up, and then if we click it, then it goes back to the start scene. Of course... Uh-oh. Did it break? Oh no, something broke. Whoa. Whoa, infinite loop. Yeah, because score was never reset, right? Score was never reset. So GameState.score needs to change inside of the end scene. Right now we have to reset it because there's an infinite loop happening. Or just, do we need to refresh the page? We need to refresh the page. There we go. Okay. It refreshed the page and deleted everything. Okay, cool. Cool, no problem. Anyway, it was working. It was working. All that we needed to do was add in the GameState.score equals 0 to the end scene after we, on our click handler, and then it would restart. But okay, CodeCademy said enough. We are moving on. Sounds good. Learn phaser, animations, and tweens. All right. Introduction to animations and tweens in phaser. A static image can only convey so much information. Imagine using a static image for a sprite and moving it around the game. Will players really get a sense of when it's walking or running? You know, that would be kind of fun. If you just had a sprite that didn't have any animation, it would just move and then float. Like all the physics would still work, but it wouldn't have any animations. Does it stay the same when it's jumping? Maybe just standing idly by, waiting for the player to take control. Instead, we can opt to use animations to distinguish between the many actions our sprites can do. In this lesson, we'll learn how to take a sprite sheet, a single image file that has a sprite in different poses, and animate it using phaser. We'll also introduce another visual tool, tweens, in our game. We'll take this newfound knowledge and add another dimension to how sprites look, move, and interact inside our phaser games. The game we're developing here is a simple platformer that will help us visualize animations and tweens. As the game develops, you'll notice we provide for you additional code that builds out the game. When you see our provided code, take some time to read through the comments and refresh yourself on what the code is doing. After all, it's all concepts we've gone over before. Now, let's breathe some life into our sprites. So use your left and right arrow keys to control coding to observe how animations correspond to a sprite sheet. All right, cool. Let's control Cody. So you can see they set up his sprite sheet here. He's got 6 different animations. Looks like he's running or jumping. But right now, we're not touching anything. So he's just breathing. He's taking deep breaths, doing some Wim Hof breathing there. Deep breaths. But when we move him around, look at that. Move him around, it cycles through. That's really cool. Look at that. It looks alive now. Very cool. But then when he stops, he immediately goes back to the idle, right? Idle animation. All right, sprite sheets. One common tool used to create animations is a sprite sheet that contains all the images that depict how a sprite can move. Take, for instance, what we just saw. As we move through the frames, or individual images, of the sprite sheet, Cody starts walking. To implement an animation in our game, we need to load the sprite sheet, create the sprite object, create the animation by selecting specific frames from the sprite sheet, and play the animation. So let's focus on loading in our sprite sheet. So in the example provided, we have a class set up to extend the phaser scene. Within the preload, they load up the sprite sheet with like the key, so the name of the sprite that you want, and then the sheet image, and then we set up the frame height and width as well. So this load sprite sheet takes 3 arguments: the sprite's key as a string, a location of the sprite sheet, and an object with the properties frame width and frame height, which indicate how many pixels wide and tall the individual frames are. Be sure to use accurate values, since inaccurate frame width or frame height values will result in a misshaped sprite or a non-functioning animation. And that's all to do with like how large the image actually is, how large you made it within your design software. Now let's load in Cody's sprite sheet. So they set up a little background for us here, a little platformer game. In the game.js file, inside of the preload, we'll call this .load.spritesheet. This .load.spritesheet. You work with spreadsheets, I work with sprite sheets. Haha. We're gonna load up Cody and have, I guess this link is where his sheet is stored. So we'll load that up there. Not sure why it's, let me add the other string. Aha, that's why. There we go. Okay, and then the last is the frame object, which has the properties of frame width. W is capitalized there, frame width 72, and frame height. And this is also, or this is 90. Okay. We won't see anything until the next exercise, but we're off to a great start. All right, great. So we don't see anything once we load it in, but we can see that nothing is broken. So now we shall create the animation. So we've preloaded it here with that sprite sheet. They also have the images of the platforms and the caves. This is really cool. This is one cool thing about reusing assets, is that the platform is populated in 2 different places, and then just duplicated over or created again in a different place. As you can see down here, they have plat positions set up as a variable, and all of these coordinate systems which set it up as an array. Okay. In fact, we didn't do our due diligence and actually scroll through all of this. We will now. How about that? We'll type in we'll get our Cody in there, and then we'll look at the rest of the code. So this logic goes inside our create method. GameState.example sprite, this.physics.add sprite, yada yada. The code above should look familiar. It's the same way we create a sprite object from a single image. When our sprite loads, it'll show the first frame of our sprite sheet. We can now use this anim's create to create our animation. So this takes an object as an argument that has several properties. Okay, so they load up their example sprite here, and then they call on the this anim's create within the create method, right? So then this method takes 4 arguments. The key, which is how the animation will be referenced. So if you want to refer to that later, you call that key, that string. Frames, which frames of the sprite we're using. And then this anim's generate frame numbers. Sprite key start and end is a phaser method that returns an array of the sprite sheet's frames from start up to and including the end. So this will take the first image, which is its index of 0, right? Just like arrays are, the sprite sheets are indexed, are index 0, and then it will take it through 0 and 5, which is going to be the 6th frame, right? So there's six frames here for that sprite key, whatever the sprite sheet is. All right, then we have frame rate. This is how many frames play per second. It'll default to 24 if it is not provided. Usually you don't need that for like a 2D platformer, right? You're not looking for super smooth, and you probably also don't have that many frames for your character either. You could, but not usually necessary. Then repeat. How many times the animation repeats? Use -1 to continuously repeat the animation. Good to know. All right, to see what other properties we can include, you can check out Rex Rainbow's phaser animation documentation. Okay, let's see how this looks in our own code. So inside of the method, the create method, first make the sprite object. So assign GameState.player the value of calling this.physics.add.sprite with the arguments of these. Let us do that. All right, so GameState, if I can get my typing going here, GameState.player equals this.physics, so that it can be affected by gravity, add sprite. He's going to appear at 255 and 500, and we want Cody to appear. If we put in like platform, then the platform would appear at those coordinates. All right, there's Cody. Look at that. Okay, so still inside create, call this anim's create and pass in the following object. So if we have Cody here, and we try to move Cody, he does not move. Cody is frozen. We have to, well, we don't even have the key inputs in there, but we have to also set up our animations first so that we have something to reference when we do our event handlers. So underneath what we just declared is the GameState.player. We're going to then say this anims .create of an object that has 4 keys, 4 properties. We're going to put in his run animation, and then the frames of that, which is the next property, will be this anims generate frame numbers. And we want to generate it from the Cody sprite sheet, and then put in the start at 0 and the end at 3. So we create another object to say when it starts and when it ends. Start at the first frame and end at the 4th frame, which would be frame 0 and frame 3. And we'll go ahead and condense that a little bit so we get that code on one line. There we go. Then after that, Next property is frame rate. Oh, yep. That comma is just hanging out there. Frame rate. This is going to be 5. 5 frames per second. We're going to repeat it indefinitely, so this is going to be equal to -1. Alright, so our animation is set up, so whenever we do, whatever input we have for the run animation, it'll generate the frame numbers, it'll generate 4 frames from the sprite sheet, and populate at, or appear at 5 frames a second, and repeat indefinitely. So no matter how long you have the arrow key pressed, Cody will always do his animation. If we had this set to like 100, then the animation would repeat 100 times, and then it would be over, and he'd just be frozen again. Okay, so then also let's look at how they, just out of curiosity's sake, how they set up the background on the platforms, right? So they have 2 files, since it's fairly simple at this point, just a single screen. Their game scene extends the phaser scene, and then they have their super linked to the scene in the config file. They added a background color, however, then they added an image on top of that. So they added the cave image as the background, and then they added platforms. So they made platforms variable as a static group, so they wouldn't be affected by gravity. Then they established their positions, which is set up of an array of objects. So then they did a for each method on the plat positions, which is interesting. So they're creating an array of objects, and then for each object they are let's see. So the element is plat. Trying to unravel this here. So plat positions dot for each. So they're calling a yeah, these are not connected. These are totally separate. So they're calling a for each method on that variable with the element just called plat, and then platforms create will enable a or display. Yeah, because there's nothing else that's displaying. So this is actually going to display it on screen of whatever the x value is, whatever the y value is, and then a platform, right? And all of that's being packed away within the objects, or rather these are being referenced as the objects, and then it's adding the sprite at those locations. So we have 4 here, I think. Let's see, 1, 2, 3, 4, 5. There's actually 5. So as you can see, you can guess like what or where the object starts and ends, where it loops, based off of these platforms up above. So we can see these two they're like the whole pieces of the platform, but then underneath and with the coordinates you can see that at 575, the y coordinate of 575, there are 3 objects, which would be down here, and then the loop points would be right in that split where the ice stops. You see that? So this whole bottom is just 3 images looped, or not looped, but populated 3 different times, created 3 different times on the bottom, to make it look like you just have a floor down here. Thank you for the follow. I think you are number 40, so thank you for that. Okay, so that's how you get the platforms to pop in. And then I think everything else is what we put in, except for they set up a collider as well. But they haven't added any logic to that collider. Okay. All right, animating. So we load in the sprite sheet. We did that. We created the sprite object. We created the animation from the sprite sheet. And now we actually get to animate it. Okay, so we have everything else set up. Now let's bring our sprite to life. Inside of update, we can include our logic for controlling our sprite and animating it however we want. So in here, okay, so they set up a listener for if the right arrow is down. Also, I didn't see if they set up their cursor keys. I guess they did so here. Remember, this is setting up like all the arrow keys plus shift and space, so that then we can add listeners down here. Okay. So if the right arrow key is pressed, the example sprite moves to the right, and we play the animation by calling the example sprite anims play movement of true. Now this is a little confusing because they are in their example our label for the animation is going to be different, but they just labeled theirs as movement. And then I don't know what the Boolean is doing there. It's just saying like yes, play it, right? Like yes, play the animations. You could also have a movement like say he gets frozen by a blast of ice or something, right? So then you could say that when you click on the animation that it's false, and then he would stop. They haven't explained that yet, but I'm guessing that's what that does. So anims.play will play the animations or a single animation passed as an argument, or if passed an argument. So we provide that with two arguments. The movement animation, which is just the animation key. And the second is a Boolean which won't play the animation from the start if it's already in progress. Oh, okay. Okay, gotcha. It won't play it from the start, so it's not going to like jump around back to the beginning in the frames. So we need that have... Actually, I don't know what or how to explain like what that's doing as like one thing, but basically it's saying that if the keyboard input is being pressed while you are running, in this case, that the animation will play through all of the frames versus like restarting every time it runs, and that way it keeps jumping back to frame one. So then you don't actually get to see your animation. It just stays on frame one. So that's why we need that Boolean there, so it actually plays through the whole loop of it. Okay, so let's do that with Cody. So in update, there is an if statement that already set up that moves Cody to the right. Inside, call anims play on GameState.player. Pass the arguments run and true to play. So what we set up before was an animation with the key of run. So then we'll go ahead and set it up here for it to play. So inside of the if statement of if cursor's right is down, this will set his velocity to 350 pixels to the right per second. Underneath this, we need to show his animation, because right now, if we do this at the moment, he just kind of slides along, and we'll have to reset it because there's no left programmed in yet. But he just slides along, and that kind of works for ice, right? But let's show him doing a little more work, trying to struggle against that ice and move a little bit more. So we need to call anims.play on GameState.player. This will have, this needs to be connected to this way. So GameState.player.anims.play, is that's stored within the GameState.player object. So then we need to play the run animation we gave him and set it to true so it plays the whole animation. Okay, so now if we press right, then he runs. And he keeps running. And he keeps running and running and running, even though we've lifted our hand off of the arrow, because we haven't set a stop condition in here yet for if nothing is being pressed to set his velocity back to 0. And then set like the animations to stop as well. We'll do that next. All right, and flipping an animation. So here we're going to code in him going to the left. So Cody's animation looks great moving to the right, but if we apply the exact same logic to move left, Cody looks like they're being blown back by some wind or doing the moonwalk. While it's cool, it isn't exactly what we're going for. Okay, let's try this out. So Cody, he's got his little, they put in their little idle animation, right? That little breathing one. And we can take a look at that in a second, but let's test this out. So he moves along. Yeah, look at that. But if we go to the left, then he does the same animation in the same order. So then it looks like he's running backwards. So we're going to flip that. We're going to make it so that those frames, or flip him entirely so that he's actually facing the left. All right. They also, so like last time we were saying that there's no, last exercise, there's no stopping condition. Well, they put that in as well. So we'll take a look at that. But yeah, so what we're doing here is to flip the X property of the animation to be true or false, depending on which direction we want our sprite to run. So then they have examples set up where they set the flip state, the flip X state, to a Boolean of either false or true. When right is down, then since he's facing the right naturally through the sprite sheet, we put that to false. When we want him to go to the left, then we just flip that and then have the same code for everything else. Pretty simple. This isn't even like, I guess this is like a property. Yeah, it's just a built-in property of the object. Okay, so when our sprite is moving to the right, we assign flip X to false. Okay, I explained all of this. And now let's add it to Cody. So let's first get Cody turning to the left. In the else if condition, assign the flip X to a value of true. So we need to find where this is. This is going to be in the update section where they have left is down. So game state dot player dot flip X, and then this is going to be equal to true. And now he turns to the left. But when we turn him back to the right, or at least try to, he doesn't flip over. Because we do have the flip X set once, but once it's set, then it never sets back to false. So we need to take the same code and add it into when he's moving to the right as well. Oops, false. So now that we have that set to false, when he moves to the right, like so, he's facing the right direction, and he turns around whenever we turn him. That's pretty cool. That's pretty cool. And the animation works both ways. It just looks so much better now that he's actually facing the right direction. So before we move on, let's go ahead and look at what they added between exercises. I want to look at the idle animation here. So for the idle animation, they strung it along with the if conditional for checking any input. And they just said, okay, so his velocity is set to 0. And that's literally all you need to make him stop moving. If we delete this, then it will be like before, where we had him going, and then he just slides along. Which honestly, that's kind of cool for ice, right? You could set his velocity to be a little bit, or like an equation where it slows down, slowly decrements over time. Set up a loop where he moves and the velocity decreases. And then get more complicated with it. Say how fast he's moving determines how long he slides, that sort of a thing. But if we add that back in, then he won't slide along the ice and he'll just stop. Okay, so then we have GameState.player, another animation, and this time they have the key of idle. So they're playing this whenever no input is given. So this is, like it says, just his idle animation. If we look for that up here, we have it underneath our run animation we coded in. They gave us this one, which is the same functionality, except it has a key of idle, and then the start and end frames are just the last two that aren't included in the running one. Now, if you wanted to have a little fun with it, put this to the running animation, which is the start of 0 and end of 3. So now, even when he's standing still, he'll still do his little running animation. So that's set to the idle and run. And that's how easily you can manipulate this by just changing those two values there. Once it's set up, you just change the frames, and there you go. We can even have it be where this, when he's running, also includes the idle animation. But it looks kind of strange. All right, I think that was everything. The idle animation and then seeing that he stops, that's done in just 3 lines of code essentially, just adding in the else else condition, and then the 2 lines there, stopping him and starting the animation. Yeah, okay, let's move on. Pausing animations. Well, here we go. We're gonna talk about this. Whoa, we got a snowman on the screen. Look at that. Snowman's doing a little dance, marshmallow dance. All right. So learning how to start an animation is one thing, but pausing it is another. When it's game over, or if we decide to include a pause option, we might opt to pause one or all of our animations. In Phaser, we can call example.sprite or .anims, example sprite.anims.pause on the sprite to put a pause on its animation. We can also call pause all to pause all animations in a scene. Okay, interesting. So let's try these convenient methods in our game. Okay, so what did they add in here? They added a little snowman. Yeah, a sprite sheet of the snowman. And where is he referenced here? Where is he initialized? GameState.enemy. That's what he's the enemy of the game. So this physics.add sprite snowman. And then they added a collider with the snowman and the platform so he doesn't fall through them. Snowman alert. That's the animation they're creating for him. Is this within? This isn't really contained within anything. They're just creating it fresh. And they're creating it on the snowman sprite, or from his sprite sheet. Cool. Okay, so then they play it. I guess they just play it all the time. Does he have any more than just the... No, I guess you can't really see how many frames you have to work with. There's got to be a way to tell that, to like call that information forward of saying how many frames does this sprite sheet have. That's interesting. I mean, usually you would know, but it would just be like if you're working with sprites that you didn't create yourself or didn't have in front of you to count. Be nice to be able to call that forward. But yeah, so the snowman is on snowman alert, and he's got 3 frames working there. And then Cody has his same functionality we saw before. Okay, so we've included the animated snowman in the middle of the main platform. We also added an overlap object that checks when Cody comes in contact with the snowman. It works very similarly to a collider, except that it allows the sprites to overlap. The overlap is in the create method inside the callback function, pause the animation of the snowman when the 2 sprites come into contact. Do this by calling enemy anims.pause. Okay, so we need to find the collider, or rather the overlap, for those 2. So where do we have that set here? So we have the collider with Cody and the platform. We have the world bounds. And then we have a collider between the enemy and the platform. And then we have the overlap. So the overlap is at the very bottom of the create method. Inside of this, we're going to pause the snowman's animation. GameState.enemy.anims.pause. Oh, hey, how's it going? So we are looking at the CodeCademy character and then a snowman inside of a little ice world. Oh, what did I miss here? Oh, I spelled enemy wrong. Enemy. Okay, we've paused one snowman animation, but let's see what happens when we pause all the... Okay, so we need to actually test this out. So if Cody runs over snowman. Okay, the snowman overlaps Cody. I'm guessing if you flip the 2 arguments here, or the two parameters. So put this to player, and switch the player to enemy. Of course, yeah, CodeCademy is like, what are you doing? Just follow the instructions. But once we have... No, the snowman still overlaps. That's interesting. Okay. So we'll switch that back. And as you can see, once Cody goes behind the snowman, then the snowman stops and he doesn't restart. So now that we've done that, let's see what happens when we pause all the animations. Inside the same callback function of the previous step, call this.anims.pauseAll. Okay, so this.anims.pauseAll. But okay, Cody's paused too. And okay, so his run animation starts, but then it doesn't loop. So it just ends at the first frame, and then it switches to the first frame of the idle, and that's it. That's interesting. So you can still control the characters, like the physics don't pause. It's literally just the animations. All right, tweens. While animations allow us to play through the frames of a sprite sheet, tweens help us refine the transition from frame to frame. By creating in-between frames, sprites undergoing changes like their size and positions appear smoother. One common usage of tweens is to convey movement. For instance, okay, let's see here. Okay, so they set up a move tween property with this tweens add and a whole bunch of properties. So, so they added the this tweens add method to create a tween saved in the GameState.moveTween, the object that they provided as an argument. So targets, which determines which sprites are affected. You could also use an array rather than just like separating by commas. X, which determines, or sorry, the separation by commas is for the properties, not this. They could use an array of what sprites are being affected by the tweening. Then X, which is the final X coordinate of the example sprite. Ease describes how the tween plays. In this case, they have linear easing. They provided linear, which means it plays at a constant speed. But if they wanted some variation, we could have provided another easing function. So in this case, like the line of it transitioning is just smooth, just constant. But the transition could be like, you know, exponential or logarithmic or however you like it for that easing. Duration determines how long the tween lasts in milliseconds. And repeat is how many times the tween runs. And like before, we can use -1 to continuously play. So that repeat one is just like we had with the animations. Then we have yo-yo, which is a true or false value. If it's true, the tween plays in reverse for the sprite to return back to its original size, position, angle, etc. Before the tween started. If it's false, then the sprite will remain as is after the tween finishes. To play the tween, we call play on GameState.moveTween. To stop playing the tween, we call stop on GameState.moveTween. Okay, so let's see this for ourselves. All right, step 1. Let's add the tween inside of our create method. Since our tween will be related to our enemy sprite, assign the enemy.move a value of the tweens. So this is inside of our create method. We can go ahead and add this at the very bottom here and just assign it to GameState, a new property, enemy.move. This.tweens.add. And then this will be that object with 6 properties. Targets. The target is going to be the snowman. GameState.enemy. It moves the sprite to the 320x coordinate. So x property of 320. Ease is going to be linear. And I guess this is also a string and then linear. Lasts for, or has a duration for 1800 milliseconds. Duration of 1800. continuously repeat this. So the repeat is going to be on -1. And then yo-yo back and forth. So yo-yo is going to be true. Okay. Oops. That's all we need for that one. Nope. Okay, let's see. Let me check my spelling and syntax here. So in GameState.enemy.move. GameState.enemy.move. This tweens add. Have an object within those parentheses. Target GameState.enemy. X of 320. Ease is linear. Duration, repeat, and yo-yo is true. With the proper argument, object that will make the tween. Ease of linear. Okay. Target GameState.enemy. Enemy.move, this tweens add. I don't know. What's off with that? What's up with that? What am I missing here? So linear, that's spelled correctly. Duration, 1800. Repeat is -1. Oh, do we need to add the play? No, it just said to supply it in there, so I'm not sure. Sure, let's check out the hint. Your code, make sure your code is inside of the create method. Well, I think it is, because it's in, yeah, I mean, it's literally right after the line that says add your code for step 1. Okay. Targets, GameState. Oh, targets. That needs to be plural. There you go. Yeah, even if there's a singular target, the key for it is plural. There we go. Now we got the snowman moving. Look at that. Look at that. Now he's patrolling. So that end condition there is X of 320, right? So if we moved him to like 350, what would happen? All right, let's try like negative, or just like 100 and try to get him off of the platform, yeah? Whoa. Game over, click to play again. Hey, they had that built in. So you can't get hit by the snowman. Okay. Interesting. So the X is actually like, what if we did 10 on this one? Yeah, and then it pauses all animations. All animations except for the movement, which apparently is like just the tween movement. Or no, that's coded in elsewhere. I think he moves on his own. Anyway, we'll set that back to 320. Did they say 320? And then do step 2 here. So we've got the tween playing, but we should also include a means of stopping it. So in create, locate the overlap object of Cody and the exit. Inside the callback function of that overlap object, call GameState.enemy.move.stop. After clearing this checkpoint, see what happens when Cody reaches the exit. Okay. So we need to find the overlap for him and the exit here. Right here. And so we can see that it's going to load up some text for us that we reached the exit. Physics pauses, GameState equals false, and then you pause all animations. So we also need to make the enemy movement stop. So GameState.enemy.move.stop. And that's all we need for that line. See what happens when Cody reaches the exit. Well, how do we control Cody? How do we know? We know we can run with him. We know we can run with him. Can we jump? I bet we can, but let's see it in the code. So down here, actually, the exit also has an animation, if you noticed. It's kind of like pulsating with its glow. So that is created here. The exit property is given that sprite of exit, and then it has five frames on its sprite sheet. And that's just called glow, the glow animation. So then they just play that constantly throughout the game, and they set up a platform between the exit and, or sorry, they set up a collider between the exit and the platform so it doesn't fall through the floor. Interesting that the exit is set up as a physics sprite. I'm not sure why they would need it to be that, because all that you're doing is going towards it. You're not affecting it by gravity or anything else. So I don't know why that's set to be, I guess so that if you move the platform around, then the exit will always appear wherever the platform is. So that's handy if you don't want to move two things at once. You can just move the one thing, and then the exit will follow it wherever you decide to put this. Say that you did it too low or something, or too high where Cody couldn't reach with his jump, so you wanted to move it back down. Be easier just to move the one thing and then have everything attached to it come with it. Okay, so let's look at the space key, if there is one set up. Yeah. So down here, Cody jumps if they are touching the ground, and either the space bar or the arrow key is pressed. So we can make him jump in two ways. So if the space is down, or if the cursor's up is down, it's the up key. And this is interesting. Never seen this before. So the player body is touching down. Means that like there's a collider happening, right? Like he is colliding with something, he is on a surface of some sort. Then this will happen. If he's not touching the surface of anything, then even if the space key is pressed, he won't jump, and that way you can stop this. This limits him to one jump only. It stops him from jumping infinitely. If you wanted a double jump, you could put in a counter there as well, where the counter is just like 0 to 2, and if he jumps once, it goes to 1. If he jumps twice, it goes to 2. After the double jump, then he can't jump anymore. But yeah, okay, so this is what is controlling our jump. Let's go ahead and see it in action. Wahoo! Look at that! He has no animation for his jump, but we can make one by pressing the arrow keys also. Don't touch the snowman, get to the exit. Woohoo! You reached the exit, click to play again. Look at that. And with just that, almost entirely from scratch. We haven't designed it, and they added a few functions for us. But basically we coded certain functions, and then they gave us more of the same. So same syntax, but more of the same, except for this. This is unique here. But anyway, yeah, with just that, with the knowledge that we have, we can create a simple platformer that has a win condition, or you reach the exit. Of course, he doesn't. It should be like overlap, right? It shouldn't be. Is it overlap? Where he can actually like get to it and make that box a little bit smaller, so he's not like floating on top of it. But we have a win condition though, and then we have a lose condition if you touch the snowman. All right, let's move on. Tween callbacks. So what if we wanted something to happen after a tween finished playing, or while it's looping? How about before it starts playing? Conveniently, Phaser allows us to provide tweens with callback functions. So to use these callbacks inside the object we pass to this tweens add, we assign the following keys callback functions. On start, if we want a function to execute when the tween starts. On yo-yo, if we want a function to execute when the tween starts going back to the original position. On repeat, if we want a function to execute each time the tween plays. On complete, if we want a function to execute when the tween finishes. Okay, got all those options there. If we wanted to remove our sprite after its tween finished playing, we would call it like this. So on complete, then you would destroy the example sprite. With our tween in place after our tween plays, the callback for on complete executes and destroys the GameState.example sprite. Let's incorporate a callback in our code. Cool. Okay, so we provided a new function, grow snowman, inside of create. We want to execute this function every time the tween repeats. Inside of the argument passed into this tweens add a key of on repeat and assign it a value of grow snowman. Okay, so we need to find the, or just provide a new function inside of create. You can scroll all the way down, bottom of the code here. This is going to be within the tweens enemy movement. And we need to set this as like an anonymous function here. We could also use an arrow function, I suppose, but then well, I guess it would be the same because we're still referencing game state, but we'll just declare it like that. So add a key of on repeat and assign it to grow snowman inside of create. Every time between repeats. Key of on repeat. Okay, so on repeat. On repeat. Assign it a value of grow snowman. Okay. And that's it. Oh, okay. So now as you check this, you clear this checkpoint. Is it working? Oh no. Run, Cody, run. So at some point, like the snowman is going to either crash the game or just fill up. Oops, I reached the exit. Oh man, I have to start it again. So now each time his animation loops, when it loops, then this function runs, the grow snowman function, which is just a simple scale change. If it's less than 4 though, so he will stop. I think it'll stop here. Oh no, he's not stopping. Scale change of 0.3. Oh, I see. So 4 is it's much more than that. So now the challenge of the game is get to the exit before the snowman fills up the entire screen and breaks the game. Is he done? Yeah, okay. Let's see if we can do it. Maximum difficulty, maximum snowman. Oh, no. That hitbox is a little large there, but oh well. Cool. Okay. Review. You did a wonderful work with animations and tweens. Good job. In this lesson, you learned about the difference between an image and a sprite sheet, loading in sprite sheets, creating animations, playing animations, flipping animations, pausing animations, using and creating tweens, and adding a callback to a tween. Using these techniques, you can make your games even more visually appealing. So you can create a jump animation for Cody if you want to challenge yourself, which it's already coded in there. And we know how to do that by referencing the Cody sprite sheet and then finding his jump, which is set up in, let's see, run, idle. Where is that one set up? We got the snowman alert, glow. Where is this jump? Where is that? It's only referenced once. How is that only referenced once? Where is it? Do they have it in another file? They do not. How did they do that? That's magic. Because the idle, if you reference the idle, it's going to be in 2 places. Once when you declare it, and then once when you initiate it here. Jump should be the same way, or else it shouldn't work. Which is very weird. What animation? Oh, okay. So he's just, yeah, he's not doing anything. Of course, you can also like change the animations based off of what key you're pressing. So I don't know if there would be a conflict between him jumping and him running if you did both at the same time. But we can't really create a jump animation unless we have the sprite sheet data for that. The way that we would do it is just initiate the jump above this. And use like, okay, so let's just copy the structure of it and then show how it would be done. So just change this to jump, right? Change that to jump. And then have it be, I think, like the last 2 frames of his run. So like 2 and 3. They look like his legs are higher in the air. We'll try that. But it doesn't, oh, we need the frame rate to be different. 2? Oh yeah, see, it happens for like a split second, but then it goes back to idle. That's interesting. Does this need to be like 0.5 to let us see it? Yeah, like 0.01. Nah, it still happens too quickly. Maybe because it's just like, okay, so 1. No, it just goes right back to, yeah. I think because that, the way they have it, like, listen for it, so it's not like, so space is down, right? So if space is being pressed, and then if there's nothing happening, but this isn't strung along with everything else, right? So it should be, though. This should be within this if statement, or else we're just going to get this where we jump and it barely appears, but then he goes back to the idle animation because it's running through this line, this code block. So let's grab this and then shift it up to the top, or at least above the else statement. Gotta be careful with my braces here. Okay, there we go. And then bring the else back. There, this becomes an else if statement. And then I think that well, let's see if that works first of all. And the same thing is happening though. So space seems to work a little bit differently than, oh, because he's not touching the ground. So basically the animation only happens when he's touching the ground. If we deleted this part, just deleted this part where he can jump, so then he'll be able to jump infinitely. However, I guess we can leave those parentheses in, it doesn't matter, but delete that part. Yeah, so now the animation continues, and of course he can jump like, yeah, he just floats around. But that's what was stopping it. So it was saying that the animation won't play unless he's touching the ground. So we actually need this to be different. We actually need to go back a few steps and change this back to down here. This will check to see, or rather, after the check completes and you do press the space bar, that the velocity will be set, right? So the velocity of y is set. But we need to copy this for another check as an else if statement. And then get rid of the part where it checks to see if he's on the ground. Right. And make sure we need another brace here. Okay, I think that's all square. So that way the animation will play even if he's not touching the ground. I think we can also delete it on the bottom one, but we'll just keep it, see what happens. Yeah, see? There we go. That's cool. Yeah, so we needed 2 checks then. We needed the check to see that he was touching the ground so that you wouldn't be able to jump infinitely. But then we also needed something to say that while the spacebar is being held down, keep playing the animation even though the character is not touching the ground. Cool. So now we have that. And of course you can override it by also pressing the arrow keys, which would just take a little bit longer to say, like, while the spacebar is being held down, don't do anything else. But yeah, cool. So now as you're jumping, as you're holding spacebar, he'll jump, and then he'll do the little jump movement there. And of course, you could have him swing his arms in the air if you wanted to, move forward more. But once you stop, so once you lift your finger off of the spacebar, then he goes back to the idle animation. So he's trying to jump, and then he stops jumping. And then I think there is no there's no input for like spacebar being held down a certain number of seconds. In that case, you could have it be where it's like as soon as you let it go, if it's not the maximum jump, then he'll stop ascending. He'll only jump to a certain height. But right now, it's just like on any click, he goes to the same height. Okay, but yeah, that's pretty cool. Pretty cool. All right, phaser animations and tweens. We're gonna do a quiz and then see what the project is coming up. So given the following between the tween and this referring to the scene object, will Cody return back to its original position? We shall see in a moment here. Make sure that everything is going fine with the stream. We'll do this quiz and then see what the project looks like. Might save that till tomorrow or the next time we stream. But there we go. Okay. Looking good. Sometimes it cuts out. I might have to check on it. But alright, so given the following tween and this referring to the scene object, will Cody return back to its original position? So Cody, this adds sprite of Cody. You add the tweening in here. Okay, original position. This referring to the scene object. There is no repeat property. Yo-yo is set to true. Ooh, yeah. Yeah, oh man, what was the difference between those two things? Turn back, I think, so he will return back to the original position, but only once. So the yo-yo is set to true, so he will return, but he won't repeat the loop. If yo-yo wasn't, if it was set to false, then he would just move over, and down or up wherever he is on the coordinate system, move over, and then not move back. But with the yo-yo being true, he would do one loop and then stop. Okay. Oh, 100, 100. That's where he's starting. Yeah. Yeah. Okay, what is the importance of calling a sprite's, or of setting a sprite's flip x property to true? Assigning a sprite's flip x property to true will automatically play its animation. No. Assigning a sprite's flip x property to true will flip it horizontally, which allows the sprite to turn and continue animating. Yes, that is true. Yeah, that's the importance of it. Woohoo! Fill in the code to create an animation that continuously plays at 10 frames per second. So we need a key of run for our hero. Hero is the name of our sprite. Frames this.anims generate frame numbers for the hero sprite 0 to 5, frame rate of 10 times per second, repeat of -1, so it continuously repeats. Sweet. So fill in the code to create a tween that goes to the x coordinate of 500. Okay. Goes to the y coordinate of 120. Okay. Plays continually and does not return to its original state. -1 and false. That's interesting. So it basically means that... How would it be if the looping condition is false, but then the repeat condition is true? So it would go, like the sprite would move to that position, and then no matter where, like say it was a ball rolling down a hill, I know there's physics and gravity and all that affecting it, but say that we had none of that, and it was just like you said that this was a ball rolling down a hill, got to the bottom, and then you would say that a player could push the ball up the hill, but whenever the player moves out of the way, then the ball would roll back down, essentially creating like a fake gravity. False gravity there. So perhaps that, like, it always returns to the same position, no matter how it's affected. Okay. What happens when the example sprite anim's pause is called? Animation is pause. Yeah, only the sprite's animation is pause. All right, if we had a sprite sheet that is 600 pixels wide and 50 pixels tall and contains 6 frames, how do we load this sprite sheet into our game? Okay, so we're going to need sprite key, sprite sheet PNG, frame width of 600, or no, sorry, yeah, 600. Or 6 frames. Okay, so there's 6 frames each. Let's divide that into 100 pixels per frame. So it'd be 100, and then each of them would be the same number of pixels tall if you're cutting it up horizontally. So it would be this one. It'd be 150. All right, fill in code to create a tween that logs high to the console every time the tween repeats. Okay. On complete, log high to the console. Or is it on? No, it's on repeat, right? Duh. Yeah, it's on repeat. They showed us in the example they gave us, it was like on complete, but then they had us type in on repeat. But since this is looping indefinitely, we want it on repeat to console log high. Okay, what would be a reason for using a sprite sheet instead of static image? A sprite sheet can be loaded locally, whereas a static image cannot. That doesn't make any sense. They both can be added locally. Okay, so using a sprite sheet creates multiple sprites at a time. I mean, it doesn't... Sure, yeah, it does create that, but then you reference it later. A static image can cause the page to freeze up. No. A sprite sheet allows us to animate the sprite and show movement. Yes. Yes. It doesn't create multiple sprites at a time. That would be like a factory object, right? It sets up frames of a sprite, multiple frames of a sprite, but yeah, it's this one. How do we play the following animation? So GameState.example sprite, this add sprite, sprite key. How do we play this animation? So we need to call the key. We need to say GameState.example sprite.anims.play, anim key. Yep. Okay. What is the correct sequence to animating a sprite? Create the animation, load the sprite sheet, create the sprite object, and play the animation. Load the sprite sheet, create the sprite object, create the animation, and play the animation. Yes, because the animation might be just a few frames. You need to actually create it before you reference it. Wahoo! All right, next project, Cody's Counting Conundrum. Okay, let's combine our knowledge of scene transitions, animations, and tweens into a single game. The game that we're going to build out draws inspiration from a game used to study chimpanzee memory. The premise of the game is that numbers flash on the screen for a brief period of time before being covered by circles. The goal is then to click on the circles in the correct order from smallest to largest. Okay, let's see what functionality they have to begin with. I don't think they have anything to begin with. We save it up. We cannot click on anything, but they do have a start scene, a game scene, and an end scene. All right. So let's start this here. So first, look over the code and notice the following pieces we've already provided. In game.js, we provided the game state object, the config object, and started our game. Yep. So game state will keep track of how many correct and incorrect answers there are. The counter property keeps track of what number is being guessed, and then the number of coordinates property is used in the helper functions to make sure no coordinates repeat. Okay. Okay. What number is being pressed? Counter of 1. Gotcha, okay. Then they set up the scenes and establish the game. In start scene, we have the start scene class sets up the background image. I don't really know why they needed to do like a whole... Wait, load sprite sheet of searching? Am I in the right one? Yeah, start scene. We have our start scene class with a preloaded sprite sheet and text. I don't know what the searching would be, but then they have text on that. I guess this is like just the background image of the peach. I don't know what that's for. They also have a pointer up on the start scene ready to go to switch over. End scene has the end scene class, preload and create, where they create the scores, and they reset all of the game state properties. So if score was over 70, then there's a certain add a happy sprite in the animation below. And then if you did not score well enough, they were going to add a sad sprite animation. Okay, game scene contains the game scene class and the logic for how the game is played. There is already code that populates the numbers and circles. We'll be adding tweens to the game scene class. So in the game scene, they have the class setup, created the circles as a group. Then they're letting the random coordinates equal this assigned coordinates. I think they'll explain that later, but it says that it uses the provided helper functions to choose random coordinates for the numbers. Okay, very interesting. Okay, and then they have a whole bunch of like generate random coordinates functions down here, and then returning random x and y values. Assign coordinates is random ones. Yeah, look at that. That's actually pretty simple. They're just assigning two random numbers based off of the size of the canvas, or the size of the player box, the background, and then assigning coordinates. That function just takes those numbers and assigns it to a variable. And then the while statement, let's see, then when they take the number of coordinates, they take the assigned one and say that the assigned one equals this dot generate random coordinates. An assigned coord is set to an x value and a y value. They're using those properties to put that into an array, which tells where the number of coordinates are. And same thing for down here, setting up an array and then returning the coordinates. And that's just saying, like, while this exists, yeah, while it exists, then the assigned coordinates is just random. And that's where the x and the y are. And then they set that array to equal true and then return the assigned coordinates. Okay. Okay, I tell you what, I will go through this next time. I'll be back either tomorrow or Monday to go through all of this with you and work out our counting game here. I think I will understand it a little bit better if I have fresh eyes on this. But so far, yeah, today we made a lot of progress. We learned how to make a little platforming game, and then learned about all of our files and how to set those up with the different classes. So we're very close to full, I wouldn't say full, but like comprehension, like basic comprehension of how to create a phaser game from scratch. Yeah, all right. Okay, well, we'll check off number 1 and then get to the rest of it next time. Thank you all for joining. I hope you learned something and hope you had a little bit of enjoyment along the way. Live long and prosper. I will see you next time. Peace.